15-minute break.
Okay, guys. So we're gonna. I want to really build on what we've just learned about data references and XREFs, but move on to discussions of some AutoCAD or Civil 3D specific objects such as alignments. We've covered surfaces a little bit, but I want to talk about alignments next. And to do that, we're going to start with another blank drawing based on the Civil 3D template. That drawing just got open a second ago. It took a minute to get it open, but now that we're open and we're in model space, what we're going to do, we're going to minimize the sheet set manager, and we're going to expand our tool space and our properties again. And what I'm going to do here is I'm going to switch our working folder for our data shortcuts to a different project within the 2017 folder. So we're going to open up this Carver's Creek job. I'm going to go to, again, SC Products, CAD, Drawings. Once that's highlighted, I'll hit OK. That'll change my working folder to this project. And we see this is a project that's a little bit further along, that we have a number of existing surfaces. Well, we have a number of EG surfaces, LiDAR, main, and small. And then we have some design surfaces, embankment crest left, embankment crest right, and an excavation CL, centerline, in the shortcut list. We also have a number of alignments. All right. Now, what I'm doing here next is I'm actually going to import a number of these objects into this new drawing. We'll go with the defaults on most of this. It's taking its own time. That's okay. And then I'll zoom extents again by double clicking on the mouse wheel. Once this is loaded, seems to be having a hard time with that surface, taking a little bit longer than I would expect. All right, zoom extents, and we see we have a broader LiDAR surface with a smaller, what looks to be a surveyed existing grade surface. A couple things I want to point out here. One thing is about hardware and computers and what it sort of takes to run Civil 3D. Now, I'm working off, for this presentation, I'm working off the workstation, desktop workstation that I use every day for my work. And it seems to handle Civil 3D pretty well. I have the occasional crash and everything, but you know, there are times when it gets overloaded. The reason I say this is that I know that a number of you may be working off of laptops and may have a fairly hard time working in Civil 3D. So what I wanted to point out is there are a number of steps that you can take if your desktop is underperforming when it comes to Civil 3D or crashing quite often, or if you're working off of a laptop, just about any laptop, unfortunately, you may notice that you have some performance degradation or more frequent crashes than you would like. And so I just want to let you know, when working in Civil 3D, there are a number of steps you can take to limit those effects. And one of those things is to be able to turn surfaces off or to dumb them down. And so first things first, this LiDAR data, we may need this data as we're working, but we really don't need to look at it right now. And so if I were to select this surface and then go over here to my properties menu and take it from contours to intent existing to no display, what I want to point out here is that data for the surface is still there in the drawing. We may not be able to see it, but if we were to draw an alignment across here and ask it to build a profile on all the surfaces within this drawing, we would see that that LiDAR data is still there. But by turning it to no display, it actually frees up some resources to allow us to do our work more quickly. That's an important thing, and when you have large surfaces, large data sets, complicated drawings, it can help you quite a lot just to turn things to no display. In this case, if I wanted to maybe dumb down the surface a bit in terms of how it's being displayed, I could also change the how it's displayed, the style. I could go to a 5 and 25 existing, or change it to a different style like border only. Again, the data is still there, but it's just not using up as much CAD resources, as much virtual memory, as much RAM and graphics memory to display that surface in our drawing. All right, for this one, I'm going to take it from border only back to 2 and 10. But I do want to point out one other feature within Civil 3D. And to make this clear, I'm going to turn that LiDAR surface back on. I'll select it here and switch it to 2 and 10 existing. So this next thing I'm going to do is specifically for, it's a setting that's specific for freeing up graphic memory while you're working. And if you were to go to the View section of the ribbon, and this Views drop down, we'll notice that there's this option called Level of Detail. Now sometimes when you open up a drawing, you'll notice that a pop-up comes up and it says, hey, would you like to enter Level of Detail mode? And you're given a choice of yes or no, basically. What Level of Detail is going to do, and here we get a warning, it says you are entering into Level of Detail display mode to accelerate display. For Level of Detail display mode, a surface with a large amount of data will be displayed at a reduced visual quality when zoomed out. To edit it, please zoom in to a higher level of detail. All right, I tend to not check these, do not show me this message again. I like to know everything that's going on with CAD, and so if you click that, you'll never see that message again. I don't recommend it. So when we close that option, with that warning, we see that LiDAR surface got dumbed way down. And as long as we stay zoomed out like this, it'll stay pretty dumbed down. But as we zoom in, more details show up. So level of detail is another way, if you still want to have access to be able to look at that data, but don't want to necessarily slow down your computer to a crawl, then you can turn on level of detail. It should be noted, and this is very important, if level of detail is on, this surface will not print. Actually, I take that back. No surfaces will print. You can't publish or print PDFs or anything else when it comes to surfaces if level of detail is on. So if you're it's really something to be used when you're working on a drawing, when you're adding additional details and design data to a drawing, but not when you get to final design level. You're going to always want to turn that off before you go to print. Okay, guys? I'm going to keep this one turned off, and I'm going to keep level of detail turned off. But I just wanted to show y'all those two features and have that brief discussion about hardware and CAD being slow, Civil 3D being slow, so that we can all be aware of that. Okay, the next topic for us is about alignments. Now, often we'll jump into a project and the alignments for the project are already created, and that is the case for this project as well. In fact, I created these alignments. Most of these alignments for this project just last week. But I want to talk to you about how to create them yourselves and have a discussion about what alignments are, what we use them for, and the sort of importance in the underlying scheme of getting something built in the real world. So here you can see I created a reference to the embankment CL alignment, and because our view annotation scale is set to 1 inch equals 1 foot, we cannot read the text very easily, so I'll change that to 1 to 20, and we can see those station labels now pretty easily. So the alignment itself is just the line and the curves and the PIs that are associated with the geometry of that line, and it's automatically set to create these alignments as a proposed alignment in our template, and automatically to generate alignment labels at 50-foot increments. So we have major label stations for every 100 foot and sort of like minor label stations every 50 foot. So those can be added and manipulated individually. In other words, if you're at whatever scale you're working at, your labels are too close, you could turn off the 50-foot increment labels or delete the 50-foot increment labels without worrying about changing the design data. And so by having an alignment in a drawing, it allows us to create a profile view. Profile views are driven by the alignments. And so to do that, we're going to use the profiles drop down up at the top of the screen and choose this first command to create profile from surface. Okay, so this left-hand dialog will give us a list of every alignment in the drawing. You want to be careful if you have multiple alignments, so you're choosing the right alignment. And then over here, it gives us the option to select what surfaces we want displayed in our profile view. So I'll go and choose EG LiDAR and then EG main. Since both of these are representations of our existing surface, we'll make sure that the style that's being used for these two surfaces is the existing ground style. There's a number of styles built into here for our profile views, including design, existing structure, final grade, foundation, and rock. And we can talk about those later. But we want to make sure both these show up as existing ground. So I'll leave those styles alone, and then I'm going to choose the option to draw in profile view. And from here, I'm just going to choose the defaults. I could go next, 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 but I'm not going to worry about any of that. I'm just going to hit create profile view and then select a location just outside of my existing grade to drop that alignment profile view. Now, what we see is going on here is we have our two different surfaces and we have a grid that is being trimmed at one of those two surfaces. Typically what happens is Civil 3D is going to choose to trim that grid based on our template, based on either the lower surface or the first surface that you add to the profile view. And you can investigate which surface is what by clicking on the profile line and then checking your properties menu to see that that's the EG LiDAR. And of course, the only other surface that's in our drawing is the surveyed EG main. Now, what I'd like to do here is I'm actually going to do something that I'm going to teach you all something that I don't teach a lot of people in terms of styles. Generally when it comes to styles, we don't like individuals to make a lot of changes to styles in their drawings. But this is one of the profile views are one of the few exceptions because profile views can display quite differently depending on the surface data that's being showed and the design data that's being shown and the scale that in which it's being shown. This is one of the few objects that I think it's perfectly okay for you to be able to edit the styles within, as long as you're doing so carefully, thoughtfully, and with a specific purpose in mind. Now, as we make edits to our Civil 3D templates, some of these style changes that I'm about to show you may make their way into the template themselves, and so you won't have to go in and make these changes yourself. So what I'm going to do is click on the profile view itself, and then right-click, and then choose to edit profile view style. Now, the profile views, almost all style editing can be a little bit daunting, but on the profile view styles, I want to point you all to a few pretty simple things. And if we're to click on the grid tab, I'm going to uncheck the option to clip vertical grid and uncheck the option for clip horizontal grid. And I'm going to hit apply, and we'll see what happened is that now we have what's known as a full grid profile view. This is a change that's almost certainly going to make it into our 2017 templates when those are ready, because we found that a lot of engineers and project managers prefer to have full grid profile views for a number of reasons. If the grid was, as it was first displayed, trimmed at that LiDAR grade, we would have no reference lines for elevations above the LiDAR line. And these reference lines can be pretty important, especially if we were to plop structures or other design line work in this profile view. It helps to have the grid going across the full thing. We obviously, as you can see here, we have perfectly square profile grids, and those are driven by other aspects of the style, which we may or may not have time to get into today. But just so you're aware, that one very simple change is handled through the Edit Profile View Style context menu when you right-click, and handled under the Grid tab to turn off the grid options for clipping horizontal and vertical grids. Many of the other changes that could take place on this are handled in the horizontal and vertical axis tabs, but we're not going to change any of those settings at this time. So we have now the profile view along the center line of this alignment, and it's picking up the ground data that is there. Looking at this, I decide, what, that LiDAR is junk. It's not representative of what we have in the field. We may have needed it at one point preliminarily in the design, but we certainly don't need it now. So what I'll choose to do is go into this profile view, again, right click, but instead of going to edit the profile view style, I'm going to choose profile view properties, and I'm going to choose to not draw the profile line for the EG LiDAR. I'm turning that off by unchecking the draw box and hitting OK. And what we see there is that line disappears, and now we're left with a profile view that has a little bit of data that's just not there. So if we go back and review our plan view, we see that we have about 250 feet of alignment that's left over with no surface data underneath it. So what I'm going to do is go back into the profile view properties to basically trim this profile view to stop near the edge of our surface data. And we can see from these ticks, it's very close to 11 plus 30. So I'll select the profile view again, right click and go to profile view properties. And this time I'm going to go to stations and choose a user specified range of 11 plus 30 and let it go all the way to the end at 17 plus 00 and hit OK. So that trims the profile view to where our existing data is and makes it look a lot cleaner and nicer. So we've got that defined channel here, which is actually representing a breach in an existing dam. Okay, is everybody with me here? Any questions on alignments so far, or profiles or profile views? No. All right, great. So when we think about alignments, they're a pretty critical aspect to getting a job built out in the field. The alignments are usually one of the first things that are staked in the field by a surveyor, and they're used every single day by contractors in the field and specialists in the field and our own geologists and geotechnical engineers in the field to determine where they are on the site. And so it's pretty critical that we make sure that we create alignments thoughtfully and with certain design and industry standards in mind. So for dam engineering, we almost always show our drawings with flow, water going up the page. In other words, the reservoir would be at the bottom of the page, and the dam would be in the center, and the downstream tailwater would be at the top of the page. Or sometimes from left to right, and especially when we're showing profile views and section views, we want to be sure that flow is from the left of the page to the right of the page. This is an industry standard, and is thus the Schnabel standard when we're talking about dam engineering. There are other standards, I'm sure, for tunnel engineering that have to do with flow or gravity or many other aspects that you're going to have to learn on your own, Laura, and maybe you can report back and teach us how those standards are applied in Civil 3D. So when we're looking at alignments, I think it may be important to point out that within Civil 3D, alignments are most typically associated with roads. And so when we talk about alignments, it's often beneficial for me to think about them as the center line of a road, and looking at the station numbers is sort of how you would drive along that road. So in this case, this alignment starts with station number 10 or 10 plus 00 and moves north and then east along that road. And so if I'm imagining myself walking or driving along this alignment, I have a left-hand side and a right-hand side. And that is actually fairly critical when it comes to flow directions and how sections and other things are cut. For instance, when we plopped down this profile view, it had a very specific style associated with it. That style is known as 1-to-1, left to right, L2R. Okay? And so it's displaying this profile view as if we were looking at a section, or a cross section of this existing site from this direction. So we're looking at this entire ground as the existing ground as it exists along this line from this view direction. Because station 10 is on our left, station, yes, okay, that's right, we trimmed it. We trimmed it to 1130. Station 11 plus 30 is on our left, and station 17 is on our far right. That's as if we're looking at it in this direction. If we were to create sections based on sample lines, we would want those to be displayed in the correct industry standard flow going from left to right as well. And so to do that, we could very quickly go up to our sections drop down and choose create sample lines as our first choice, and then select our alignment. And here we have several options. I'm going to leave this name blank. It's one of the few things that I don't actually name in Civil 3D, but I will change the sample line style to no plot and the sample line label style to section name no plot. And then while we're in here, I know I don't want to show the LiDAR at this point, so I'm just going to go and turn that off. We're not going to sample the LiDAR at all. And then double check that my EG main is going to show up as an existing style. Very similar section styles as we have with our profile styles. So it's existing, I will hit OK. And now it's asking us where we'd like to place our sample lines. So for now, I'm just going to grab some representative stations. We'll grab station 12. And if we look in our dynamic input, it's asking us to enter the left swath width, and then see that it defaults to 50 feet. I'll leave the default. And then the same thing for the right swath width. I'll leave the default of 50 feet as well. We'll go up here to 1300 and hit enter twice to accept the defaults. I'll put one more at 1400, enter twice to accept the defaults for links. So we're basically putting a section every 100 feet along this alignment. Okay, now I've got a number of sections in place across the existing grade surface. I'm going to right click to exit the command, and we can see that we are left with sample lines that are labeled with their appropriate station numbers. So we have, looks like we've done pretty good with our object selection, and we didn't accidentally click off to the side of either one of these stations. These are dynamic, and I'll show you how that dynamic nature works in just a second after we've created our section views.
What did you set the no plot?
Okay, so when we, the question was here by Corey that what did we set to no plot? So we went to the sections drop down and create sample lines. The first step was to select the alignment we wanted to create the section lines on. And now that we're in here, because there's not a new alignment, that option is not available. But what we set to non-plot was the style for the sample line itself. We can see here that it's set to no plot. The different options there are plot or no plot. That's it. And the other option that we chose to no plot was this label. This is an automatic label that's generated with the sample line. And we set that to be set to a style that's called section name no plot. Okay? And we'll get into that in just a minute, why we choose not to plot those Civil 3D specific objects. So now we've created a number of sample lines across this alignment and across the existing grade. What I'd like to do now is go and insert section views for these sample lines. So I'll go back to the sections drop down, and in this case I'm going to choose create multiple section views. When dialog comes up, make sure that I'm choosing the right alignment, and we only have one sample line group that's associated with that alignment, so we'll leave that alone. This section view style, 5D GSO, this is an old style that's carried over from a very old template, and it's one of these things that I plan to make improvements to in future templates, 2017 template to be specific, but I'm going to leave that exactly as is now and hit the next button. Here's very important. I assume that Civil 3D expects you to place these section views in a separate drawing, and that's why this option is set by default. We always choose the draft option so that we can place these section views directly within our model space that we're currently working in. So this is important, and everything else can be accepted to defaults. That's one of the only things that we're going to change, and we're going to go ahead and hit Create Section Views. Now, since we have a number of these, it's going to create a whole group of section views. I'm going to place them, try to place them all underneath our profile view here. Once I selected a location, it placed a whole group of them in a certain order. So the way that this cluster of section views is developed is based on that 5D GSO style, which will need to be updated at some point. So we can see these are 100-foot sections with the 0 being our alignment location, and both positive and negative numbers to represent the spacing or offset of those from that alignment. So we went 50 foot to the right and 50 foot to the left. I mentioned that these objects are dynamic. So if I were to change the location of any one of these, I decided that, you know what, 1300 is not really what I want to look at. I want to look at 1350. I could select that location. The label is going to change automatically. My section view label is going to change from 1300 to 1350, and the ground is automatically going to be updated to sample the ground at that location. Okay? If I were to change the length of any one of these sample lines, that will automatically be updated as well. So we can see this one got really big, and I may need to move this other one so they're not overlapping. All that's dynamic. These sample lines default to be perpendicular to your alignment. There are special cases, and I will say it's very, very rare, but there are special cases when we will need to show skewed alignments. I suggest that you create some representative line work with a default or with a def points polyline to use this. This is, again, a very rare case that we would ever need to create a skewed, but perhaps you have a pipe or something that's coming through this alignment at an odd angle, and you want to show what the existing or proposed ground is doing. It is possible to skew these, and of course, that will, let's see, we were looking at 1400. That will automatically be reflected. The ground, as it goes across that sample line, will automatically be reflected there. That's not what we're going to do in this case. I just want to show you that that is possible. Basically, Control-Zing my way back to where it was. All right. So now we have our alignment in place, our existing grade, and some sample lines and some section views that we've created. And we can see, based on the small change that I made to this sample line, when we extended the right-hand side by several, maybe by 100 feet or so, we can see that we have our sample lines going in the correct direction. In other words, reservoirs on the left-hand side, and our downstream tailwater area is on the right stream, on the right side of that section. That's exactly how we wanted to show it, and that's entirely driven by the alignment direction. So our alignment direction is pretty critical component of our eventual layout of some of these elements. So do we have any questions on alignments, profile views, or section views so far? Everybody doing okay in here? All right. Good to hear. So guys, we are already closing in on the time that we were anticipating quitting. We're hoping to quit right at or right before noon today. So I want to keep going without any further breaks because there's still a lot more to cover in just these very, sort of rudimentary Civil 3D topics before we keep going, or before we finish today. So now that we've created some of these objects, I want to go ahead and bring in some additional data from the Data Shortcuts menu. And we're going to bring in some final grade design data. So we have an embankment crest left, and so instead of showing it with the exist to intent existing style, I'm going to choose to show that in a proposed style, which is going to change the colors for how those surfaces look. There we have our left embankment. Anybody tell me why this is called the left embankment, even though it's sitting over here on the right-hand side?
Which way is downstream?
Yeah, say that industry standard. This is the left-hand side of our eventual spillway. When we're looking downstream, this is known as the left abutment. This is known as the right abutment. So we'll bring in the right-hand side as well. To intend proposed. All right. So now we have some proposed grade. But you know what? None of that is being shown on our profile or section views that we've already created. So to get that information into those different types of views, there's two different methods that we're going to use to make that happen. So the first thing, the same method that we use to create this profile view, we're going to use to add the final grade surfaces to this view. So I'll go back to my profiles dropdown and I'll go back to this command to create profile from surface. Now here, make sure that we're using the right alignment, and I'll add, these are now new to this list, the embankment crest left and right, and then I'm going to highlight these two by holding down the control key, selecting them both, and then changing both their style at the same time to final grade. All right, and hit OK. Now I do not have to click draw in profile view. If I did that, it would actually create a separate copy of this profile view, which we don't need. At this point, I'm just going to hit OK, and we'll notice that the final grade for that top of dam at the center line at the embankment at the alignment location has shown up exactly where we want it. Okay, looks pretty good. We'll leave it at that for now, and then show you how to add that design data to your section views. For this, we need to go back over to the plan view and select one of our sample lines, and then we're going to right click and go to sample line group properties. And we see here that there's only one piece of data that's being referenced in the sample line group, and that is the existing ground main. We'll click on this button to sample more sources, and then we'll have the option to add both design surfaces. This one won't let me select both at the same time, so I have to change them individually to final grade and final grade. And then we can hit OK. And OK. What happens next is interesting because this happens by default, is we actually get a whole bunch of labels that are associated with this new surface. These are grade break labels for the most part, where they're going to give you some information about the elevation and grade break offset for to various points across that surface. This is not generally how we don't use these labels very often. And so I'm just going to, if I right click and hit select similar, it should grab all of them. And I'm just going to delete those from the profile, from the section views. You notice here that we've got a small gap in our existing ground surface. I wanted to point this out earlier, but I'll point out now. At station 15, if we were to go investigate that plan view, we can see that station 15 crosses right over a small internal boundary within our surface. This is the location of some existing buildings and walls, and we'll go and bring in our XREF so that we can see that information, what's going on there. But when our sample line crosses that, it leaves it as just simply a blank. If we wanted our our section views to reflect the new visual style of our profile view, we could do that very easily through the style editor. We could select this a section view and go to edit section view style, and then uncheck the very similar options that are under profile views to clip those vertical and horizontal grids, and then we get those full grids across the entire view. In a similar way that we were able to edit the station range for our profile view to limit this one to 11 plus 30 so that it wouldn't show the entire area where we have no survey. If we wanted to change the extents of these views in terms of their elevations, we could do that through their individual section view properties. We've already learned that if we want to change their extents in the offset, we do that by grabbing and extending the arrow on our sample line. So if we were to say that, I really don't need to show any borings or anything that, this far, what is that, 50 feet or so below the surface, we could go in and select a profile, an individual profile view, and ask to go to the section view, and ask to go to section view properties, go to elevations, and determine, say, we really only want to show this from, let's say, 140 to 190. And that's going to shrink that whole thing down quite a bit. It may be too much, but just showing you that this is available. This one goes up to 190 as well. We go to section view properties. We may decide that we want that one to stop at the bottom at 140 elevation. And so we can do that across the board if we'd like to. Unfortunately, those need to be done individually. So. Oh, wait, we're going from that. 140 may be a little high. We'll go to 130 on this one. All right. So now we've got our section views with our design data, and things are looking pretty good. Let's go and bring in our XREF for the 2D line work existing for this project. Choose the defaults for this. Zoom extents. And now we can see that there are some objects, some buildings and walls within that surface boundary. There's also quite a bit of text from the surveyor that's on the def points layer that's there for our benefit and no one else's. And if we wanted to, we can go ahead and push this layout, create a view for this layout within our layout space. This is sort of building on everything that we've been talking about today, which is making things look good for final print. And so within here, I'll create my MView object again. I'll make sure that that's on the def points layer. And I'll create my user coordinate system based on the alignment data. I noticed that there's some surface stuff going on here. I'm going to quickly turn this to no display so that I'm sure not to grab the wrong thing and end up with that triangulated surface again. So UCS command will select something on the right hand side of the spillway, and then over here, and then execute our plan command based on the current UCS to display this. I'll go ahead and pick a scale. Let's go with 1 to 60. That's too far out. And then I'll go back into the prospector to turn that surface back on. You know, 1 to 30 is probably still too big. Let's look at 1 to 20. Okay. Oops. All right, so now this information's in. We're still missing a key thing in this picture, and that is our proposed spillway. I'll go back into model view and then reference in that piece of line work as well. That's going to be under drawings, base drawings, proposed. Uh-oh. Oh, that's right. I can't use this as an example because it was set up incorrectly. Maybe it'd be a teachable moment. We're closing in on the end of our time together here. So I'm not sure if I should show y'all what was done incorrectly on this project. This is a limits of disturbance line, but we could, while we're here, go ahead. We'll leave that blank for now. It's a long story, but we'll leave that blank for now. I am going to go and create another MView for our profile view. We'll put that on the def points layer as well. And we'll zoom in on this puppy and then let's see, we chose 1 to 20 for our top view. We could choose 1 to 20 for this one as well and see how it looks. Region to make it be redefined on, all right. This may be a little bit big for this sheet at 1 to 20 because what we're seeing here, guys, is, this alignment is curved, but when it comes to the profile view, it's flattening everything out. And the distances between objects is the same, is 1 to 1, but it takes a bit more paper space to show that entire alignment with a curve in it at 1 to 20 than it does in the plan view. So we may have to change the scale and or limit our profile view once more to be more reflective of what we want. We're going to need a title block in here. We'll go ahead and do that. Again, that's under base drawings border. Scale issue of 12. What did we forget to do? What did Yates forget to do this time, guys? Forgot to. Yeah, I forgot to draw my little fake north arrow. I've been hammering that on you guys, and I forgot to do it myself. I'll switch to the depth points layer and draw my north arrow. Go back into paper space. I'll expand that down just a hair. And plop in my north arrow. All right. So it looks like I'm probably going to have to make a decision about this. This just doesn't look very good with my elevations going right off the page here. Even if I were to extend this viewport all the way to the edge, oh, maybe it will work. Yeah, maybe it will work. What we want to do here, guys, is make sure that we have elements of this drawing lined up together. So when I typically show a plan and profile view, I want to make sure that my station 1450 is exactly in line with the 1450 on the profile view, and that these two things are in alignment, if at all possible. Now we're going to notice here, because the curve is that we are going to have to make some decisions about what we show and what we don't show. So I just drew a quick reference line from the center of 14 plus 0, 0 down to this profile view, stopping it at the border of the profile view. And what's great?
Alignment in the profile view go in 2 different directions.
Yes. Good call. Good call, Corey. All right, what Corey just pointed out is our alignment and our profile view are going in 2 different directions. And that's something we would want to fix before we line these things up. Even if I were to get this puppy moved over, we're 14 lines up with 14, it's not going to line up because 1500 is here and it's lining up with 1300. That's not what we want. So this is getting back to this industry standards thing. We want these two things to line up, our plan and profile view. So we actually need to go back in model space and change how our profile view is being displayed. Now, if you remember, I pointed out that this profile view style is called 1 to 1, left to right. We can switch it, reverse it to 1 to 1, right to left. But what we're going to notice very quickly is that the style of that profile is very different. Okay? Now, this is pretty important and is going to get back into some of these edits that we made earlier in terms of full grid. You'll notice that the stationing and the grid itself is quite different. We have these long grid lines in the left to right direction and these relatively short grid lines in the top to bottom direction. These can be edited in the profile view style as well. It can get a little bit tricky to mess with this stuff, and I'm not gonna mess with it right now too much. But I do want to go ahead and get this thing lined up in our plan and profile view. So again, we're going to take the 1400 and line it up with the 1400 above, and see how much real estate that leaves us in terms of our view. It looks like we're going to probably want to cut off this profile view before the end maybe it's 16 plus 50. Yeah, somewhere in there. That'll line up. That'll give us a nice little edge. So I'll jump back in here, go to the profile view properties, and change that to 16 plus 50. Okay. We're still lined up at 1400. Everything's good there. Make sure that that's all regened. It's looking pretty good. There would be a number of additional steps. Now, Corey asked a little bit ago about like multi-leaders and annotation, and specifically the question of annotating within paper space or within model space. Now, I'm going to tread a little bit lightly here because I was actually asked specifically about this question by one of the project managers in Westchester. It seems that there are some pretty opinionated people about this topic in Westchester, and I'll try and tell you how I feel about this in terms of the sort of pros and cons when it comes to annotation. Here in Greensboro, we tend to annotate almost everything in paper space. And there are a number of reasons for this. And there's at least one drawback to doing it this way. And so if I first make sure I'm on the right layer, we're going to go to the C-Anno layer and drop in a multi-leader. So the multi-leader command is mleader. And these are style-based as well. But I'm going to use the mleader command, and I'm going to shift right-click and grab the nearest because I just want to grab this alignment. And I'm going to come out at a nice, see it's defaulting to sort of a 45-degree alignment, a 45-degree angle. I'm going to plop that there, and then it gives me the ability to type in a message. And I'm going to type in all caps, embankment, centerline, alignment. And then I can affect how that looks with this, this slider here. And we'll see that it shows up like this. One thing I'd like to encourage everybody to use with multi-leaders and MTEX and dimension objects is something known as background masking. So when you select one of these objects and look over at the properties menu, you should see down towards the bottom of this option something that's known as background mask. If we were to select yes for multi-leaders, we'll see that it puts a mask that obscures anything below it. This makes this a little bit more readable and clean looking, and it's how I'd like most people to use. You could see when we do, which we've already worked with a little bit, our contour labels, that those automatically have a background mask associated with them. I'm going to switch this one to proposed, proposed major labels. There. Oh man, I didn't lock my viewport. It's the danger of not locking your viewport, guys. All right, we're back to 1 to 20, and I'll lock it and drop that label back on there. Okay, so background masks can certainly help with legibility. And when it comes to annotating in paper space versus model space, this in some ways is a preference. I will point out that there are a number of advantages to annotating in paper space. When you click in here, and I very seriously doubt that it's going to happen to me right now. But I'm just going to click on here and click on a few things with multi-leaders and label them. All of these objects have been placed in model space through the viewport. And I'm going to select one and then right click to select similar so that I can apply background mask to all three of them at the same time. Now, if we were to look at this Let's see if it's doing what it sometimes does. We have example 1, looks okay. Example 2 looks okay. But what I'd like to point out, and this is very subtle, and you may not even be able to pick it up on your screen there, guys, is that what's going on with this piece of text that's in paper space, it's actually drawing that text much cleaner. Not much, it's very subtle, but we're getting some slight differences in the way that text looks in paper space versus model space. It's not doing what can happen though. What can happen with model space dimensioning and model space annotation is that you have everything that looks the same. Like we could say that all 4 of those objects pretty much look the same in terms of how they looked. But what we've seen in the past and noticed it on multiple jobs is that occasionally you can have annotation objects within model space and some of them appear differently. You've got some that just look bolder than the others and some that look normal. But for some reason, when you're working through model space, either it's clicking to a desired elevation and then using some of the cut plane definitions to define how that piece of annotation looks through model space. It's for that reason alone. Well, for 2 reasons, we've chosen to go with mostly paper space annotation to avoid that. The other aspect of using paper space annotation is fields. In other words, if I want to insert a field to another drawing within this set, so I'm going to say CWG, and I'm going to hit Control F here instead of right clicking and inserting field. Insert field works as well, but Control F is the keyboard shortcut for inserting field. All right, I'm going to go here to sheet set. I'm going to change this to the current sheet set, Carver's Creek. All right, what we see here when we've got a more filled out sheet set is we actually get the option to point to any existing drawing in the set. All right, and I'm going to go and I'm going to click on CO1 and I'm going to ask it to only give me an uppercase drawing number and hit OK. I'm going to say C drawing CO1. Oops. For alignment table. Okay? And I'll expand this out so it looks like a cleaner call out. All right, embankment centerline alignment, CO1 for alignment table. All right? And if I were to, open up that sheet set, let me see it. Carver's Creek. No, no. Go to open. There it is. All right, so that's pointing to this drawing, which I'm pretending there's an alignment table on there to define that centerline alignment. If I were to go in and decide, you know what, we've decided this isn't going to be CO1 anymore, it's going to be G01, or actually it's going to be G03 because we've got the cover sheet and the legend sheet before it. But we would now want this existing site plan to be in the general series instead of the civil series, and it's now called G03. Okay? Well, if I want that to update, and it's going to automatically happen if it's right here in paper space. In this example 2 that's taking place in model space, okay, so now I've inserted a field into model space into that multi-leader, and I'm going to go back into my sheet set and be told by the assistant project manager that the project manager was off his rocker, and that should definitely not be in the general series. It's a civil sheet, and we're going to change it back to CO3. Oh, thank you. CO1. We're going to change it back to CO1. What we'll see when we regenerate the drawing now is that one of them updated and one of them didn't. And so this is one of the reasons we tend to try to do a lot of annotation in paperspace. The only real drawback to doing annotation in paperspace is sometimes when you're working with dimensions, they will not work properly and you will be forced to use them in model space. Here may be a good example. I'm just going to try and dimension between these two. Yeah, when you're dimensioning surfaces, oftentimes through paperspace, it just won't work. And so you're going to be forced to use dimensions within model space itself to get a more accurate dimension. And just like with our paperspace annotation objects, we're almost always going to want to use that background mask. Here it's in a different location. It's called fill color for dimensions. We'll go here and select background. Okay, but when it comes to dimensioning structures or other line work within this drawing, annotating within using dimensions within paperspace usually works perfectly without any sort of hitch. It knows what scale the drawing's at, and it can define that length very, very easily. With surfaces, there's just more going on there in terms of elevations and stuff like that. It wasn't able to determine the model space length as quickly and easily, and so it gave me a paperspace length of 1 inch plus. And that's why I was forced to put this one into model space, but I was not forced to put this dimension in the model space. It's living in paperspace. Okay, any questions about what we've done so far in terms of alignments and alignment directions, section views, profile directions, style editing? Is all this stuff pretty clear to everybody? The intent here, guys, is to sort of introduce a lot of these topics to you guys, and so that you can know that they're there, and so you can do more research on your own. It's not necessarily all intended to be this is giving you this class and now you're done. You've learned it. You don't have to learn anymore. For most of you, really none of this is going to sink in until you get involved on a project yourself and you're working in this stuff day in and day out. So it's normal that it would take a few iterations of working with this stuff to really get it nailed down. That's the intent of these classes, to get you introduced to it, to get you a certain level of comfort with it, and then you can move on your own and develop these tools as necessary. Do we have any questions? All right, guys, I really appreciate everybody showing up today. Tomorrow, we're going to show you how this proposed grade was created using an object known as a corridor. So this is for your design engineers and people that really want to get down and dirty with Civil 3D, can learn the ins and outs of creating your own designs within the program using corridors and grading features. These are all really nifty stuff, stuff that we've customized and developed in-house for our use, and we'll show you how it all works and how you can get to something like this pretty quickly and easily. I appreciate everybody coming today, and I hope you have a good rest of your day.